Remember, this is a review. This is a review. Maybe we are doing some problem in the lecture. Yeah, repetition again. For example, the first one is repetition, but I want to explain in detail. Okay, like I want you are doing the test on papers and detail. No work for an alpha, no calculator. Show me your work in detail, step by step. Okay, the first one say, evaluate this double integral by changing the order of the integration. I need to change the order. The order of integration is given is dy first and dx secondly. So I can see the y, the limit is that y is bounded between x and pi. Que es el límite que corresponde with the first integral, que es this. And x, que es the second, is bounded between 0 and pi. Okay, with this information, I can do the sketch of the potential region in which the student set up this integral is doing. And remember, you take first this equation. This equation is y equal pi. So you convert to equation, no? Y equal pi. Y equal pi is a horizontal line whose height is pi. Another equation is this, is y equal x. And y equal x is the line passing through the origin. We set this point. Therefore, this famous point maybe is also pi because it's y equal pi, no? So the intersecting point between this line is the famous point pi. So this x value is pi, this y value is pi also. And the order of the integration is dy first. Si it's dy first, I suppose that the guy who are doing this integral are doing in this direction, so are doing vertical. And after extending from 0 to pi and x. This is the order. Guess given. I want to change that order. To change that order, well, we have two possibilities, no? Vertical or horizontal. So you extend the first dx and after expand in that way. Now you need to find the x value of this bound and the x value of this bound. Okay, so when you set out the new integral, double integral, the integrand function doesn't change, stays the same. I change the order, now the x and the y secondly. Okay, so es from x equal to 0 to x equal to y, que is the equation of this line. And when you extend it, in the second piece of the integral is dy, go from 0 to pi. Okay, I change the same region, but a different order of the integration. Okay, so to you, the first integral you are doing using the x and the integrand function. We are doing this integral first. Okay, this integrand function is I copy. If you want, I copy. I don't know if it's good for you or not. Some people prefer never separate the integral, but whatever. You copy one like a partial problem, no? So you integrate with respect to x. You forgot, you ignore temporary, of course, dy and the second integral. This integrand function do not depend on x. Now you consider it like a constant, and you put outside the integral. And the integral from 0 to y, dx, integral dx is x. Okay, let's do it. Integral de dx es x. Antiderivative es x. Entonces sin y over y is x evaluating between 0 and y. When you evaluate y es y, and when you evaluate 0 es 0. Entonces, basically, sine of y divided by y times y. And this y is cancelled, and it stay alive only sine y. Okay, we come back to the beginning. Okay, so now I copy the second integral, this one, 0 to pi, of the result of the first integral that was sine y dy. Okay, antiderivative sine is minus cosine. Evaluating between 0 and pi. This minus stay outside, and you evaluate cosine pi minus cosine 0. Okay, cosine pi, I remember get -1. Cosine 0, I remember get 1, but we have a minus in the front, so -1 and -1 together is -2. And -2 and negative is +2. And this is my final answer. Any question? What part is confusing? Come on, guys, this is a moment to ask me any question. This is the review. Okay, in the test, no, but now, yes. Please, using the microphone or using the chat. Anything you don't understand very well. Annette, Brandon, David, Shagir, Jocelyn, Hadi, Victoria, Daniela, Daniel, okay, 50, Marco, and Omar. Everything is clear. Come on, guy, I need communication. Answer me. Professor, yes. Okay, yes, clear. Jocelyn said yes, clear. Do you remember the ID before this problem or no? Okay, clear. Okay, super. No problem. I move on to the second one. No question, clear. Okay, let me do question 2. Question 2 say, using double integral to find the volume of the region bounded by the cylinders, and I need to find volume using double integral. The double integral is possible. Find the volume when you put here the function. No? The integrand function is the s equal to z. Is equal to z dA. And the region in our problem is bounded by the cylinder. This is x squared plus y squared equal 1. It's a cylinder, right? Remember, this is circle, but it's in 3D it's a cylinder because the surface, I know que con el one variable M5, in this case z, is because the cylinder is along the z-axis, no? The cylinder is obvious, cylinder. The surface. What kind of cylinder? What kind of cylinder? Circular cylinder. And what kind of circular cylinder? Along the z-axis. Okay, I can do that sketch now. And also the plane is equal y. Okay, this is a plane. And what kind of plane? Well, it's a plane. Like every plane is flat. It's obvious, no curvy, of course. However, when the one variable is missing is x, I suppose that this is tending along the x-axis. So let me try to do my best to do the sketch of both surface and try to understand what is my solid, what is my region, my 3D region, no? This is x, this is y, this is z. Okay, then first of all, we have a cylinder. A cylinder, the radius 1. We have one here, cylinder. Wait, I forgot something important. Okay, it's in the first quadrant. First octant, sorry, octant, no quadrant. opt. And that means that X is positive, Y is positive, and Z is positive. Okay. Entonces no down, only up. No in this quadrant. No, 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 no. In this quadrant. No, 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 no. Okay, entonces my cylinder look like that. Entonces es infinity in this direction alone. No, no down because it's bounded by the idea for the first quadrant. How you do the plane? Well, the plane is okay. Look. When for example, I suppose in order to find the intersecting, suppose que C1, Y1. So one point here is a point 1, okay, suppose que is a point C equal 1, and Y equal 1, entonces es like that. Okay, and this is alone the, okay, along the x-axis, no, because x-axis is missing. Okay, this point 1, and this is 1. Okay, this is the plane. So the plane intersecting with the cylinder and forming one figure like that, I suppose. Let me try to do my best. Okay, look. Here it's connecting, touch. Entonces I suppose that this is the roof of the solid, and the walk of the solid is something like that. Entonces when you set up the volume of this solid using double integral, the integrand function that you put it here inside is C, and C is equal Y. You put C, or much better, you put Y. Because I want to put like a function of X and Y. Entonces Y dA in the region R. And who is the region R? The region R is the region. Okay, listen. So basically, let me use in green color. The high is this. Okay, is the Z value of the plane. That is the reason why. However, in order to understand the region R, I'm projecting, okay, onto the XY plane, because basically it's a 3D picture, no? 3D picture. Now a 2D picture look like, suppose XY. Remember, there are different kind of 2D. You can do several. Well, in my opinion, the most important is XY. In this case, not always. It's a quarter of circle. A quarter of circle. Ow. A quarter of circle. Okay, 1. So basically, this is this. The base. This is the base. Okay, so now, in my opinion, the best way to set out the double integral in this case is using polar. How do you know get polar? It's polar because it's a circle. On a circle, semicircle, quarter circle, the full circle, es obvio que es much better doing in polar, ¿no? Entonces now, si es en polar, let me set out this double integral in polar. Entonces I put the integrand function as y. No y anymore. I know que en polar x is equal r cosine theta, y is equal r sine theta. Okay, entonces I replace y for r sine theta. And don't forget the Jacobian part. Okay, always the same is r dr d theta. It's a classical. Always is the same. Well, these r and these r together is r squared, no? But in another step, I set up more elegant the integral. Now, I am building little by little construction, set up the integral and the limit. Okay, suppose the first piece of the integration is dr, and dr go from 0 to 1. And theta go from 0. 0 is exactly on the x-axis, 0 degrees, 0 radian, to 90 degree, que is pi over 2. Okay, 0 to pi over 2. So we almost be ready for solving this double integral. Entonces basically is integral from 0 to pi over 2 equal sign, I forgot, integral from 0 to 1 r squared, because r and r together, dr, and sine, well, stay here, sine theta d theta. Entonces I can separate. In this case, it's possible doing in that way because not always, guys, you see in this review package, we can separate, we cannot separate. In this case, we can separate because the limit is a constant, so we can compute separately this integral, and the result of this integral, your multiplication by the another integral, include only theta. So when okay, two reasons to separate, okay, it's possible. Number one, limit is a constant. Number two, the integrand function is separate variable, separatable variable. So when you have, for example, my function is two pieces. One piece can contain only r, and another piece can contain only theta. Another piece can contain only theta. It's separable. Suppose it's r plus theta. No, we cannot separate. We can separate when you use multiplication time here in between. This case is easy. Okay, entonces now it's obvious that this is r cubic divided by 3. Evaluate in between 0 and 1. And when you evaluate, 1/3. 1/3 minus 0 and 1/3. I did the upper. Antiderivative sign minus cosine. Again, it's similar. Wow. Minus cosine theta. Evaluate in between 0 and pi over 2. It's minus parenthesis or bracket, whatever, cosine pi over 2 minus cosine 0. Cosine pi over 2 is 0, cosine 0 is 1, negative and negative together is positive, the answer is 1. And 1 times 1/3, the answer is 1/3. It's a volume. This solid. Any question? Any question? Come on, I want to hear your opinion. Opinion. Everything clear? Confusing? Clear. Anne, Brandon, David. Come on, guys, say something. At least to say hi, professor. Anne, are you there? Brandon, are you there? Hi. David Restrepo. Chayir. I am what? Her. Clear for me. Okay, Jocelyn, clear for you or no? Hadi. All good, clear. Okay, super. We are the best in Miami-Dade College. By the way, guy, I have curiosity, very curiosity. I need to know if everyone is a student officially of the Miami-Dade College or you are studying at another university. I know que Giraldo, I know the story of the Giraldo because I know personally. And Ricardo also. But for example, Anne, you study in Miami-Dade College? Officially, or you are taking this class in the summer? Oh, in Miami-Dade College, in what campus? In which campus? Annette, no answer? Annette, no, sleeping. Brandon, Miami-Dade or another university? David Restrepo a Miami-Dade, Ponte Campo or no, or another university? Miami-Dade. What campo, Brandon? What campo? Ponte Campo. Ponte. Okay, super. David Restrepo. You say something I forgot. I don't see very well. Miami-Dade, no? And what campo? Miami-Dade o Omar dice Miami-Dade. Miami-Dade, a ver, West Campo. West Campo David Restrepo. West Campo. Ok. Miami-Dade Kendall. Jocelyn. Uy. Heidi. Marco, you say something? Yeah. Okay, I understand. Daniela, Miami-Dade or another university? Because the boss asked me, where come from 24 students? Victoria, are you there today or you are sleeping again? Oh, no, I used to Miami-Dade, different university. Okay, Miami-Dade. What campus, Victoria? Ponte. Okay. Okay, super. I'm a little bit now informed where you come from. Okay, let's do it. Moving on to the next problem. Number 3, easy. Number 3 no, is easy also. Number 3 is again double integral. Double integral. Double integral. Number 3, double integral again. Let me see. Yeah. This double integral is given. Okay. The limit is from 0 to 1. 3y. 3. Okay. The integrand function is exponential. X squared. Dx dy. Okay. And the question says similar, no? Evaluate the integral by reversing the order of the integration because it's impossible doing in that order because the antiderivative of the e to the x squared is impossible. No, antiderivative e to the x is super piece of cake. Es e to the x plus c, ¿no? Pero antiderivative e to the x squared, no antiderivative. Bueno, okay. Listen to me. It's important that you understand that when we use software, Wolfram Alpha or graphic calculator, no? And you put any integral, the software or the graphic calculator immediately understand that the antiderivative do not exist. Therefore, the software or the calculator try to solve it using a numerical method. Numerical method of the integration or numerical method in general in mathematics is another subject of the mathematics. But you don't care. Well, you see something in calculus 2. You see, for example, integration using midpoint, using trapezoid rule, using Simpson, is the most sophisticated. Yeah, there are more methods sophisticated. But the thing is, the calculator or the software understand it's impossible compute the antiderivative, pero es possible compute the defining integral. Entonces, use numerical method, pero bueno, how do you know? How do you realize que calculator software using numeric? Because, bueno, maybe it's a long process, o sea, spend some minute to give me the answer. However, the answer never is in the exact answer. So, how do you know it's exact? When you see radical 3 plus 1 over 2 pi, it's exact because you see irrational number. However, when you see the answer is 0.49999 or something, entonces es decimal approximation, and I suppose that the software or the calculator uses numerical. Okay? Entonces, we can do, yeah, we can. We can do directly here this without changing the order or reversing the order. Well, the problem is that in the test on paper, we need to show me the word in detail. I said, no, impossible. Entonces, let me try to understand the order of the integration. Integration first with respect to x. Entonces, x vary from 3y and 3. Good. And y vary from 0 to 1. When this information and you separate like equation, so actually I know that this is inequality, right? However, in order to understand my region, temporary, I convert to equation because I suppose que the equation is the boundary que limitate the region. Entonces, x equal 3, well, I know que es a vertical line, like that, vertical line, x equal 3. Vertical line, I don't do that, good. X equal 3. Okay, x equal 3. The second equation que es this, is 3y equal x. Oh, much better, at least for me, is divided by 3, so for y, is x over 3, no? This is a line passing through the origin, of course, and it's slope 1/3. Entonces, this guy is 3, entonces this guy is 1. Entonces, wrong and rise, wrong is 3, rise is 1. This is my line. My line, y equal x over 3. Entonces, now, the region, okay, so somebody can set up this integral doing for this line to the 3, but doing in this direction. But let me use in red color. Okay, how do you know? Because it's dx. O sea, the elementary infinitesimal area que you stretch, remember this is elastic, no? Was in horizontal direction. So this is x equals something, and this is x equals something, no? Es obvio que es 3 y es obvio que es 3y. So the guy que set out this limit thinking in this direction, in the red direction. But I need to switch it, reverse the integration. And after, to understand completely the idea, extending in this direction gets from 0 to 1. Because, by the way, this point is a point 3,1, no? 3,1, yeah, 3 divided by 3 is 1. Y is 1 value, so extending in this direction. Pero no. I need to change. I need to reverse it completely, this order. No. I understand now. The red part was the understanding. However, I need to change in this order. dy first. Well, entonces dy go, I suppose, to 0, to y equals 0, que es this level, to this y. Well, this y is this, no? Is finally extending in this direction from 0 to 3, x. Okay, I understand now. Ready, set up the double integral. The integrand function stays the same. Nobody touched that. But you integrate dy first and dx secondly. Entonces dy go from 0 to x over 3. Okay, the y value, this is y2 and this is y1. Okay, but no necessarily. Some people like put the y. I don't like. I don't know why. This is a style. And finally, extended from 0 to 3. This is my double integral. This is the most important guy. The rest is super elementary idea. You, for example, compute this integral first. If you want, you copy separately here. 0 to x over 3. E to the x squared dy, but you are doing the integration with respect to the y, and you consider que the function que dependen only de x es a constant. Entonces, e to the x squared outside the integral. And your integration dy with respect to the y, and the derivative is just y. Evaluate in between 0 and x over 3. I'm plugging in. Bueno, es x over 3 plugging in, and 0 is 0. Entonces, 0 is not important, it's irrelevant. So far, we have e to the x squared times x over 3. Okay, this is the answer for the first integral. Moving on to the second one. The second one is integral from 0 to 3 numerical of the function que es 1/3. I suppose que 1/3 is a constant, no? I put outside the integral, so they put x e to the x squared dx. And this is a classical integral that we are solving by substitution. Exactly what we are doing in Calc 2. The classical substitution is u equal x squared. And the u is 2x dx. In order to complete the differential, we need 1, 2 here. When I am happy, see, I include 1, 2 here because I know that 2x and the x together is the u. But in order to doesn't affect, you multiply artificially by 2 and divide by 2. When you divide by 2, this 3 is not 3, is 6, no? Because 2 times 3 is 6. So we have 1 over 6 integral. Now we have e to the u du. Wow, fantastic! Because x 2x dx was du. But I need to modification a little bit the limit, no? Because these values 0 and 3 correspond for the variable x. Now, in our new integral, we have the new variable auxiliary, que was my friend to make easy the integral, que is u. Therefore, x0 corresponds to u0, and x3 corresponds to 9. Okay, integral this is 1 over 6 e to the u, evaluating between 0 and 9. 1 over 6. Wow, it's raining out here. E to the 9 minus e to the 0. Bueno, e to the 9, I left like that. And e to the 0 is 1. Entonces, 6 is the common denominator, e to the 9 minus 1. Something like that. Could be the final answer. Any question, guys? Any question? So far, clear. So far, everyone have 100 points in the test. Remember, let me repeat again. The due date I want to change because I want to help my student, no? The due date for this test is June 5th. So next Monday. Next Monday, no? Next Monday, yeah, next Monday. So we have one entire week for doing that. Do you see one noise? Wow. It's raining here. We go chances to online also. Yeah, Jocelyn. Okay. Okay. Online, I want to change the due date also. I am not doing that. Okay. No. I want to change, of course. So June 5th is our due date for both, for online and paper. Okay, I want to change the I want to change everything, the homework and the test. Okay. Wow, it's too rainy heavy. The problem is that my office is out the house, no? I have one terrace Entonces the roof is the aluminum, no? Entonces when it's raining heavy, do you see? But you hear me very well or no? I can take laptop. Yeah, I go outside. Pero no, I suppose que no. Let me increase a little bit volume. Yeah, I suppose que you hear me now. Okay, let's move on to the question 4. Question 4. Question 4. Okay, question 4 say, evaluate the integral. No, see, evaluate the integral by converting to polar. Wow, polar now. Convert to polar. The double integral is given is in Cartesians, xy. It says double integral from -3 to +3. And 0 to square root 9 minus x squared sine x squared plus y squared dy dx. Okay, this is the double integral given. I need to evaluate change to polar. Wow, too heavy noise. Okay, what is the order of the integration? The order of the integration is dy first. Therefore, y vary from 0 to square root 9 minus x squared. And x is the second. X vary from -3 to +3. So with this information, I have a little bit information to understand the region. This is my first equation. If you square both sides in order to eliminate the square root, you put a more elegant way to understand much better. This is a circle. That's a circle. It's a circle where the radius is 3, and the center is located at the point 0,0. Let me try. But is the full circle or a semicircle? How do you know that? Is a full circle or no? Or is a semicircle? Well, I suppose que es semicircle. How do you know that? Because, look, this is a square root. So this y is equal to square root 9 minus x squared. Yeah, I take the positive. It's a semicircle. The radius is 3. Okay, I suppose que somebody que doing this integration are doing in this direction. This is y from 0 to the circle and extending x from -3 to +3. This is the idea in Cartesian. But no. I need to change to polar. Everyone follow me so far? The noise allow you to understand or no? I suppose. Okay, I follow. Okay. I follow you. Okay. So let me try. Remember, to convert the double integral in Cartesian from Cartesian to polar, we are doing several steps. Step 1 is, why not convert the integrand function to polar? Okay, fortunately, I know that x squared plus y squared is equal to r squared. Because when you rewrite the integrand function using polar, es obvio Can you try to modification the function? Because now the x and y gets Cartesian variable do not participate in the game of the border. So this is sine r squared. R squared. The Jacobian is r dr. Okay, I know. Okay. dy dx or dx dy, and polar is r dr dt. I proved that one day. I don't remember. Entonces now the first integral is with respect to the r. The r vary from 0 to 3. And theta vary from 0 degree or radian to pi. Okay, and this is my integral. I can separate, of course I can separate. This is the beauty. This is the beauty. The beauty is that we can separate this integral in two integrals. One integral is depending only of the theta, 0 to pi, the theta. And another integral is depending only of the r. Look, because it's sine r squared r. This is sine r squared r dr from 0 to 3. Very well. Separate into integrals. This is a piece of cake. Because integral d theta theta or in between 0 and pi. This is pi. This no. This is a little bit more complicated. Integral from 0 to 3 sine r squared r dr. I take care, only r. I apply substitution. What kind of substitution? Well, again, u equal r squared. Du is equal to r dr. To complete the differential, we need the 2 here. One extra 2 here. In order to doesn't affect, I divide by 2. So I have 1/2 integral sine u du. And u vary from 0 because r goes 0, 0, 0, and u is 0 to 9. Okay, ready. Antiderivative sine is minus cosine. So negative 1/2 cosine u, evaluating between 0 to 9. So is, let's see, is negative 1/2 bracket cosine 9. I suppose que 9 is the radians, 9 radian, no? 9 radians, no degree. And calculate always radian minus cosine 0. So 0 radian, no? But this is 1. Okay, so the answer is, well, the answer is minus divided by 2. Entonces es cosine 9 minus 1. Oh, I don't know if it's much better. 1 minus cosine 9 over 2. Something like that. Whatever. Either way. Any question? Let me make it soon to see the entire problem number 4. Okay. Of course. Daniel, remind me, Professor, you forgot that pi. Okay, entonces multiplication by pi. Let me try. Entonces 1 minus cosine 9 over 2. Paréntesis over square bracket, more elegant. I forgot in my paper. This is the final answer, super final answer. Multiplication by pi. Multiplication by pi. Multiplication by... Ah, no, no, no. I did in my paper, yes. In my paper, I have multiplication by pi. Yes, 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 yes. Any question? Hey, how do you feel? How do you feel? I suppose at the beginning, I suppose when you see the first time multiply integral, you say, what the hell is that? This is complicated. No, no, it's not complicated. When you understand very well and you understand the procedure to solve it. Okay, now number 5. No problema, guy. Everything is clear. Okay. I want you, all good. I want you say, go to read my professor, when you pass this class. And you say, no, this professor explained very, very well, very, very clear. And the test is relatively easy. Well, no easy, because the last test, number 4, is super hard. Very, 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 5 very, remember, 5 very, very hard. So you need to be aware for this situation. Test number 4, so this is, so you believe que test number 3 hard, multiple integral, test number 4, que es the vector calculus, is extremely hard. Okay, number 5 question. You evaluate double integral again of 0 to y, 0 y, 1 square root 2 minus y squared. The integrand function is x plus y, and the order of the integration is dx dy. Entonces you go to polar, convert to polar, polar coordinates. Okay, let me try one more time. The order is dx. First, let dx go from y to square root 2 minus y squared. Okay, and x go, and y, sorry, go from 0 to 1. Now with this information, I can, using our imagination, of course, try to understand the region. No? So I take this like equation, and this equation is x equal square root 2 minus y squared. If you remove somehow the square root, because I want to understand a little bit more clear the equation, to say you have x squared equal 2 minus y squared. So you have again x squared plus y squared equal 2. It's a circle. It's a circle where the radius is radical 2. It's a circle. And the center, of course, is located at the point 0, 0. Okay, so with this information, I have at least the first boundary. And by the way, again, is the upper semicircle, right? Like that, something like that. And the radius is radical 2. And the other equation, radical 2. And the other equation is this. Case y equals x. Y equals x is a line. It's a line like that. We set the first quadrant and the third quadrant. Okay. So I try to understand the guy que set out this integral is doing in that direction, because it's x first, a horizontal direction, and go from the x equals something to x equals something, and this x equals something is the x of the line. Okay, the line is y equals x. It's obvio que this x is y, and it's obvio que this x is the x value of the semicircle, que es square root 2 minus y squared. And after he or she, I don't know, extending in this case from 0 to 1. Entonces supposition que this point is the point 1,1, no? Make sense or no? 1,1. Yeah, there's my 1,1. Look, the x value is 1, the y value is 1, and the hypotenuse, que es the radius of the circle, is radical 2. Okay, I understand now a little bit what is the order of the integration. Okay, some students or people, I don't know, set up the double integral. Okay, but what is my goal? My goal is completely different. My goal is chain to ball. So basically, this is my region. Yes or no? This is my region. I need to, okay, so I need to chain to ball. I need to chain to ball. I need to chain to ball. Okay, this is my double integral. Double integral, look, double integral. Okay, first of all, I need to change the integrand function. I need to change the integrand function. The integrand function is, wow, it's x plus y. I know that x in polar is r cosine theta, and y in polar is r sine theta. I know also that the Jacobian is always the same, is r d theta. Therefore, we have double r. So we have r squared, parenthesis, cosine theta, plus sine theta. And we have no r dr because the one r is this r. I include inside this. That is the reason I write r squared, dr d theta. Okay, super. I like that. And what about limit? Well, the limit is easy. The limit is radial limit is from 0 to radical 2. Look, this is my region. Look, and I integrate in polar. I integrate like that. The r go from 0 to radical 2. Entonces theta, you extending, you open the piece of pie like that. Look, this is d theta. Oof. This is d theta. And the action for the integration is extending this piece of pie from 0 degree or radian, sorry, whatever, to this angle que I suppose que es pi over 4. It's obvious que pi over 4, right? Because it's the slope 1, and tangent pi over 4 is 1. Entonces from 0 to pi over 4. Okay, super. Okay, I can separate this in two different integrals. Of course I can't. I can. One easy, one complicated. Okay, in this case is the theta part is the complicated is from 0 to pi over 4 of the cosine theta plus sine theta d theta. You take this, the integrand function, one piece, and the theta, and the limit. And another integral, of course, in between the mathematical operation is multiplication from 0 to radical 2 r squared dr. Okay. Well, this is a piece okay. It's a piece okay because this is r cubic over 3 evaluating between 0 and radical 2. Entonces radical 2 es radical 2 cubic over 3, ¿no? 0 es 0. Entonces radical 2 cubic es like radical 2 times radical 2 times radical 2, ¿no? And radical 2 times radical 2 es 2, ¿no? Entonces 2 radical 2 over 3, ¿no? At least the answer for that part. The answer for the second part is no big deal. You separate into integral. Oh no, not necessarily to integral. You find the antiderivative. Antiderivative cosine is sine. theta. Antiderivative of the sine is minus cosine theta. And you evaluate between 0 and pi over 4. Okay, let's do it. Entonces, well, this sine pi over 4 minus, wait a second, minus sine 0, no? Okay, minus, minus sine 0 minus cosine 0, no? This is radical 2 over 2. This is 0. This is 0. And this is 1. Okay, this is radical 2 over 2. So we have double minus, no? Minus positive, plus. It's plus 1. Now let me see, what's the mistake? 2 radical 2 over 3, radical 2 minus. Yeah, got it. I'm crazy. This is pi over 4, no? Yeah. Okay. So you evaluate this function in pi over 4. Okay, this is pi over 4, no? This is pi over 4. And the mistake was, let me see. Mistake. Okay, you evaluate in pi over 4 first. This is sine, and this is cosine. Coño. Cosine pi over 4. You evaluate pi over 4 here, upper. Now minus sine 0, cosine 0. Well, you know, sine pi over 4 and cosine pi over 4 is, well, both is the same. Radical 2 over 2, radical 2 over 2, and something minus something is 0. Unfortunately, that part is 0. And that part is 0, and this part is 1. It actually is positive 1. And then now multiplication 1 is invisible multiplier times this. The answer is this. The final answer is 2 radical 2 over 3. Boom. Any question? I do a mess here in the last part. I suppose que I lost the energy in the last moment, so I distraction my brain. I don't evaluate correctly, properly. Okay. This is all sometimes happen, at least in my brain. Okay, any question? Are you feel strong in conversion from polar? Remember, several steps. Do the sketch of the region. You need to understand very well the region, number 1. Number 2 is change the integrand function. Put the Jacobian, okay, always is the same in polar, and try to find the limit. And limit is completely different idea, because in Cartesian we have two possibilities: x, y, like that, or like that, x first, y second. But in polar, no, in polar it's r, always is r, and the theta is like that, around. Any question? No? Super, strong. Okay. Now number 6 question say, find the volume of the solid which the vertex is listing some point in 3D. This is easy, but it's maybe long. Okay, this is typical for the test on paper, no? So I like this question, no? Okay, this is 1,1,0. This is another point, is the point 0,0,1. And finally, the last point is 1, 0, 1. Let me see. In total, we have 1, 2, 3, 4, 5, 6 points. No? 1, 2, 3, 4, 5, 6 points. Okay, let's do it. Okay, because I need to understand the solid. What is the solid? Well, the solid is, let me try to do my best. X, Y, and Z. I plot the point one by one. 0, 0, 0 here. I'm using another color. Red color. This is 0, 0, 0. The second point is 1, 0, 0 here. It's supposed to be 1 here. 1, 0, 0. Second point. Third point is 0, 1, 0. 0, 1, 0 here. 0, 1, 0. Good. Fourth point is 1, 1, 0. So X, this is X, this is Y, this is Z. So it's on the X, Y plane, no? Like that. This point is the point 1, 1, 0. Okay, next point is 0, 0, 1. Is this point here. 0, 0, 1. And finally, 1, 0, 1. There's 1 in X, this is X, Y is 0, and Z is 1. This is C. I suppose it's this. Here. This point is the point 1, 0, 1. Okay, ready to connecting this point by segment line. One segment here. One segment here, one segment here, one segment here, one segment here, another segment here, another segment here, another segment here, another segment here, and this is my solid. Using my imagination, well, the solid is a prism. And the prism, I suppose, the roof of this prism is this plane. Okay, the base is this square. And we have lateral wall, is this triangle and this triangle. And what we have in the back, another square. Okay, I understand. Do you understand the prism? Boom. It's the technical name of this guy. Okay. Entonces, I need to find the volume. Entonces, the volume, bueno, I suppose the volume, in this case, why not? We're using double integral or triple integral, either way. However, okay, if you make a decision to use the double integral, I need to find okay, suppose I integration in this direction. Look at that, from this to this. So from C equals 0 to the C value of this plane. Bang. Okay, I have no idea. So I need to find the equation for this plane. I need to find the equation. So now we take your knowledge about the chapter 1. In the chapter 1, we found, for example, using 3 points. Okay, maybe the 3 point I am using is this point, and this point. Either you select 3 points, arbitrary, not necessarily this point. And you, for example, using this 3 point, we determine this vector, in this direction. Suppose I make a decision. There are many ways to do this, but I want to complicate a little bit using vector, equation for the plane. But we can use intuition. But no, let's do it in a formal way. The formal way is, suppose we have a vector here. Okay, this vector, the green vector I see here is the vector 1, 0, 0. Ah, guys, this is the I vector, right? 1, 0, 0. Because the magnitude is 1, in the same direction of the x-axis is I vector, so we're right. And we have another vector, is this vector. Pointing in that direction. And this vector is, I call vector A. This is vector A, okay, by the way is I, but one. You have vector B. Okay, vector B, remember the formula. Okay, we have to find the vector between 2 points, and the vector B gets this vector point in that direction. The arrow is pointing to the 0, 1, 0. So you're subtracting the x component, y component, z component. 0 minus 0 is 0. 1 minus 0 is 1. And 0 minus 1 is negative 1. This is the vector AB. However, see, you perform the cross product A cross product B, you get a normal vector. Let me try to do the sketch of the normal vector. Okay, by the way, it's exactly the normal vector que we need to define the equation for this plane. Entonces, I want to skip the stupid cross product. It's too long. No, it's long, but okay. It's a chapter 1. I passed this chapter. Okay, when you perform the cross product 1, 0, 0, cross product 0, 1, negative 1, give me this vector, que es 0, 1, 1, positive. And this is in the equation of the plane. I know that the equation for the plane is a x minus x null plus b y minus y null plus c z minus c null equals 0, no? It's the equation of the plane, no? It's another one possibility, no? We have another equation que es ax plus by plus c equal d, no? But this is analogous. This and this is the same thing, because d is the multiplication a x null, b y null, and c times c null, and when you move to the right hand side, it's exactly the same as this, no problem. However, what is the coefficients ABC? Well, this is the coefficients ABC, que is the coefficients of the normal vector. Okay, es 0, es 1 and 1. O sea, this guy is 0, this guy is 1, and this guy is 1. And who is C null, X null, Y null? Bueno, es the point que I take like a pivot, que es this point, que es this. Entonces, X minus 0, Y minus 0, and C minus 1. Something like that. Well, I manipulation a little bit. This is 0, it's gone. This is Y. This is C minus 1 equals 0. Therefore, my famous plane is the plane C equal 1 minus 1. Boom. Okay, too much, eh? Too much work to get the answer. Is y equal 1. 1 minus y, sorry. Is this plane. Take the equation for this plane. This plane. Okay. This is a little bit about geometry in 3 dimensions. Find the equation for the plane when you have 3 points. Okay, now, I am ready to set out the double integral, no? double integral, double integral. Okay, volume, volume, oy, volume, volume, double integral. Okay, double integral. Wait. Entonces, what is my integrand function? What is my integrand function? What is my integrand function? I am confused. What is my integrand function? Well, my integrand function is the high here, right? So suppose I am doing using double integral because I can use a triple integral, no? I can compute the volume if you want using triple integral. Triple integral. Y you suppose que the integral function is 1. Okay? Pero let's do it in both ways. Suppose now que I'm using double integral. And double integral, the integral function is C. Es this one. Es this. Is, look at that. The integral function is here. Let me erase this question mark. 1 minus y, que es the C value que representa the height of the roof of the prism, of the solid. Now, by integration, I don't know exactly dA. I have no. In this case, dA. Entonces, in order to do the second part of the region R. Entonces, who is the region R? The region R is the projection in the XY plane. Entonces, I need to do the graph in 2D. The graph in 2D. This is the graph in 3D. Now this is the graph in 2D. XY. Entonces, XY represent square. Yes or no? Represent square. And yes, of course, it's square. Entonces, this is 0, this is 1, this is 1, this is the 0.11. When I suppose que C is 0, it's the projection onto the XY plane. Okay. Entonces now it's easy, at least for me it's easy. Bueno, this area, no, this double integral is double integral. Suppose que I make a decision. See, there are no problem. I don't know why. In my brain, it's much better integration in this direction. Sometimes no, sometimes it's impossible to say you need to switch the order. But in this case, no. Suppose que there are no problem. I prefer, personally, I don't know why, integration vertical. So when you integration vertical, it's obvious y, no? Entonces, okay, the integral function stays the same. It's 1 minus y. You integrate with respect to y. Y go from 0, y equals 0, to y equal 1, que is the horizontal line, 0 to 1. And when you extend it, go from 0 to 1. Okay, let me solve the double integral. And after, by curiosity, let's see how we set up the idea using triple integral, okay, by the way, is the same. Okay, so now you take care this integration first. I focus it. You copy that. 0 to 1. 1 minus y. dy. Wow, super easy. Calculus 1. Integration 1 is y. Integration y is y squared divided by 2. Evaluating between 0 and 1. Entonces this is 1 minus 1 half, no? It's 1 half. It's 1 half because it's 1 minus 1 half and 0 is nothing. Entonces now my second integral is integral from 0 to 1 again. And the result is 1 half dx, no? Wow, super easy. Entonces 1 half is a constant, integral dx is x, evaluating between 0 and 1. Es obvio que this is 1, multiplication by 1 half, the answer is 1 half. 1 half is the volume of this prism. And this is obvious, guys. This is no big deal. Because this prism is a half of the cubic like that. Look. 1 cubic like that. It's a cube, no? Suppose that any side of the cube is 1. 1, 1, 1, 1. The volume is obvious que es 1, no? But this is a half of this. So it's obvious that the answer is 1. Pero no, okay? Okay, I try using calculus. Maybe another more complicated example, but let's do it by curiosity. This is completely out of the game using triple integral. In triple integral, the integrand function is 1 because it's volume and dv. Suppose que I'm using z simple method. Okay, I prefer. Sometimes no, sometimes it's much better y or x, but c simple que es integrate. So the first integral doing using in the c direction, and c direction go from 0 to the c value of the solid, que es 1 minus y. Okay, now after this is dz, sorry, this is dc, integration first, and after dA, okay, dy dx, either way, it's exactly the same, it's the same region. So the rest is doing the double integral. So you are doing this, the triple integral, but you perform first the integral z, because I make a decision to using z simple. And after we have the problem get double integral, and double integral by coincidence is the same region, no? It's logical, no? From 0 to 1 and y, from 0 to 1 and x. And the story, you see that this and this is the same thing, because when you integrate the first integral, the integral dz is z, evaluate in between 1 minus y and 0 is 1 minus y. Entonces now my triple integral is reduced like a double integral. Any question? Any question? Okay. Number 7. 7. Okay, 7 now. Yeah, any question? This is the moment. Come on. This was the heck. It was a heck. What mean heck? Yes. Yeah. This is important. Never mind. I need to find the dictionary. What the heck? Heck. What is synonym of heck? It was a good question. Oh yeah. I'd say, okay, you expect to see in the paper, test on paper, this question exactly the same with the same number, huh? Okay. Heck question. Important. Synonym of heck is important, no? Okay. Let's move on to number 7. I suppose que number 7 is the last one for today. We have, how many in total we have? We have 13, 14. Okay, we have at least we spent today doing 1/2 of the review. Wednesday we are doing 1/2 of the another review. Entonces I suppose que Friday we start new chapter. Amazing, exciting. I am excited to start the new one. Okay, number 7. Number 7 is, number 7 says set up. Well, actually, I do not set up only. I set up and solve it. But okay, set up. So see, I asked you set up. So say you set up only the triple integral and not necessary to solve it. Bueno, si es evaluate, yes. You set out and solve it. Okay. Entonces, the triple integral using cylindrical. Wow. Coordinate. Remember, cylindrical is the extension of the polar, no? Is one possibility, C, R, theta. You stay one variable in Cartesian, maybe Z is the most popular, depending on the geometry of the problem, maybe Y or maybe X. However, C is the most popular. In this case, you're using C, of course. Because my solid is bounded by the paraboloid. The paraboloid is C equal 1 plus 2x squared plus 2y squared. It's a paraboloid, and the plane C equals 7. Okay, this is okay. I need to find volume, no? Es volume, no? Let me see. No, es computed. Es volume. Compute volume. Don't say clear que es volume. ¿No? Yeah. The volume for the solid. This is a solid formed by two surfaces. Entonces, the first surface is a paraboloid. Okay, by the way, this how do you know? Because x and y are square, no variable is missing, because we have c, but however c the exponent is 1, entonces paraboloid. And this paraboloid open up, and this paraboloid have the z-intercept and 1. So when the x is equal to 0, and y is equal to 0, and the paraboloid c is equal to 1. So we have intersect, z-intercept and 1. Okay, so let me try to do my best in 3D. This is the complicated part. However, you can use in your algebra if you want. But today, no. Today is only bar. X, Y, and your solution, no? Of course, you can use in your algebra. Okay, the first paraboloid. And just I forgot something only. First octave. Remember what means to be first octave, no? Entonces, I discovered que the y-intercept is 1, the z-intercept, sorry, and the paraboloid open up like that. However, it's bounded by z7, so this is 1, and this is 7, I suppose. Okay, so my paraboloid is bounded, in my opinion, look like that, no? The plane, c equals 7 is a plane like that, boom. It's a plane que cut off the paraboloid in 7. Okay, entonces this is my solid. Let me remove the plane because it's not important. So you understand a plane C equals 7 is a plane parallel to the XY plane, no? Okay, entonces my solid is formed by this. Okay, and this is the proof of this solid. Everyone understand very well the solid? Because es obvio. Entonces es obvio que the best way to set out this triple integral is using cylindrical. O sea, cylindrical, but of course cylindrical in which we using C, R, theta. Because I can see que C vary from the Z of the paraboloid to the Z of the plane. Using, C simple. However, the intersection between that surface, paraboloid and plane, generate one shadow and the other plane like that. No good. One shadow in the plane like that. Remember the idea? The idea is you intersecting two surfaces. Okay, it's bonded my solid. This is solid, guy. This is not hollow. This is solid. So we have something inside. Okay. Now you're intersecting two surfaces, and the intersection, okay, by the way, I can see it's a quarter of circle, no? You're projecting onto the C. You see the view. This is the view. This is 3D view, and you see in 2D view. Remember, super important to do at least one 2D view because we ending in one double integral. And we have maybe a quarter circle. Get this quarter circle. And by the way, what is the radius of this quarter circle? I have no idea. What is the radius? Okay, you're intersecting this and this equation. So this equation is 7, is the C value, is equal 1 plus 2x squared plus 2y squared, no? Okay, entonces I try to move this one to the other side. 7 minus 1 is 6. It's equal to x squared plus 2y squared, sorry. 2y squared. You divide by 2, entire equation. Okay, entonces 3 is equal to x squared plus y squared. Wow, I can see clear now. I can see I have a circle. Oh, no, actually it's no circle, it's a quarter circle, but the radius is radical 3. And the center is at the origin, 0,0. At this point is radical 3. And this point is radical 3. Okay, super. This is the region of the double integral. Okay, this region in 3D. Okay. Now, ready to set out and compute the triple integral. Well, the triple integral, let me try it here, is triple integral 1 to 3. 1, 2, and 3. The integrand function is 1 because it's volume. It's volume. The Jacobian is always R detail, but I forgot the most important. Remember, you have dV. Now, who is dV? dV is dV, and cylindrical is dc r detail. The order is not important. So dc first, r detail. Okay. Entonces C. Bueno, C go to the paraboloid. This is C1, que es C of the paraboloid, and this is C2, que es the C of the plane. Que by the way is 7, no? So this is 7. It's obvious que es 7. This is C2. This is C1. So what is the C of the paraboloid? C of the paraboloid, I go to the equation for the paraboloid, look. Is this. But unfortunately, the equation of the paraboloid contains variable that is not good in this setup, this integral. This is xy que es Cartesian, ¿no? Entonces, pero I know que okay, this is C is equal 1. You factor out 2 here. And we have x squared plus y squared, que es r squared. Ooh, I like that. Okay, entonces C1, que es the paraboloid part of r squared. C1, que es this. Let me erase this. I don't like this. C1 is the integral go from the paraboloid, que is 1 plus 2r squared to 7. This is the first integral, it's C integral. Now, the double integral, I go to the 2 dimension in polar. The radius go from 0 to radical 3. And integral go from 0 to pi over 2 because it's a quarter circle like that. Pi over 2. Everyone saw that or no? Oh, time is over, carajo. Okay. Entonces we continue. So I stop here for a moment. I finish. Actually, we set out the triple integral. I calculate the triple integral. Well, okay. Let's do it in Wednesday. Wednesday we continue the review. I suppose that today was very good. Okay, everyone understand very well, or no? Clear, guys? Clear? Jocelyn, Heidi, clear. Okay, guys. Okay, so now stop recording.